Good morning friends. Today we are going to see the next point from the topic mechanical properties of fluids, that is the fluids in motion. Friends, this is the total theoretical part, so I have written the total notes. So it will be very easy for you to dictate the notes. Okay, so friends, what is the fluids in motion? Generally, you can perform an experiment that if you are walking on a plane surface of road, then note down the speed for covering the distance of 1 meter. Now, same distance you have to cover in the water, then you can observe that it will take some larger time. So that is due to the opposition of fluid when you are performing the motion. Okay, friends, now we'll see what is the hydrodynamics. The branch of physics which deals with the studies of properties of fluids in motion is known as a hydrodynamics. Now when we are studying about the fluids, then already we have seen that the fluids is a flow of liquid or gases is known as a fluid. So here we are going to see only regarding the liquids, and when we are studying about the hydrodynamics, we should know some important definitions. So here I have written some important definition. Steady flow. What is the meaning of the steady flow? If the pressure or velocity of the fluid is constant at a given point, then the flow is known as steady flow. So if the liquid is moving in a given tube, and if its pressure and velocity is constant throughout the total motion, then the flow is known as the steady flow. Next is the flow line. When the liquid is flowing, then it is following a specific path. So the path of an individual particle in a moving fluid is known as a flow line. So we can observe when the liquid is moving, so flow line will be created. Next is the streamline. So when we are saying about the streamline, actually streamline is not a path, but it is a one kind of the tangent which will indicate where the liquid is moving. So what is the streamline? It is a curve whose tangent at any point in the flow gives the direction of velocity at that point. Suppose the liquid is moving in the tube, and if I have drawn the tangent, then the tangent will give us the direction of the velocity. So that is what the streamline. So what is the streamline? It is the curve whose tangent at any point in the flow gives the direction of velocity at that point. Next is the flow tube. So flow tube is an imaginary tube. So it is the bundle of total flow lines. If flow lines are combined in one tube, then the flow tube is created. And remember, the liquid, when we are saying about the flow tube, then the liquid is not moving outside the flow tube. So here it is an imaginary bundle of flow of lines bound by an imaginary walls. So here you can assume that this is the diagram of flow tube, and flow tube is made up of the flow lines, and this will indicate about the area. Now next part from this topic is regarding the streamline flow. Friends, basically there are two flows which are included in your syllabus: streamline flow and the turbulent flow. So what is a streamline flow? It is a steady flow in which the adjacent layers of the fluid move smoothly over each other. Example, the steady flow of river. So in simple words, I can explain this once again. When a liquid is moving with a constant velocity, then the different layers are created, and all these layers are moving with the same velocity, then that flow is known as a steady flow. Okay, so here we have taken the steady flow of river. Generally, we observe that the surface of the river, and if there is no disturbance in the atmosphere, the flow is moving with a constant speed, and that we can call the streamline flow. Again, we can take the example that the liquid which is moving through a pipeline, that is also move with a constant speed, then we can say it is a streamline flow. Friends, here I have written one indication, Rn less than 1000. So for the streamline flow, the Reynolds number is less than 1000. So what is the Reynolds number that we are going to see later on? So Reynolds number is a pure number which will indicate whether the flow of liquid is a streamlined or turbulent. So remember, for the streamline flow, Rn means the Reynolds number have the value less than 1000. Next is a turbulent flow. What is the meaning of the turbulent flow? It is a flow in which there is no fixed pattern of flow. So if there is no fixed pattern, it can move randomly in any way. Here I have given one example of flooded river. When the flood will occur in the river, in the water is moving in any direction, so that is the example of the turbulent flow. Again, the water which is falling from the waterfall, that also do not have any kind of a fixed direction, it is moving randomly, so that is also the example of the turbulent flow. Friends, for the turbulent flow, Rn with the Reynolds number have the value greater than 2000. So what we can say regarding the streamline flow and the turbulent flow? For the streamline flow, the Reynolds number have the value less than 1000, and for the turbulent flow, the Reynolds number have the value greater than 2000. And if the value is between 1000 to 2000, then what we can say that the streamline is get converting into the turbulent flow. Okay, so generally we can take one example that the water is flowing through a pipe, and we have put our hands in front of the outlet. Then it is observed that through the pipe it is moving with constant velocity, but when we have put our hand and the water is moving randomly, so we can say that the streamline is get converted into the turbulent. That is the example in our day-to-day life. Again, remember one thing regarding the MCQ, that for the streamline flow, the Reynolds number has the value less than 1000, and for the turbulent flow, the Reynolds number has the value greater than 2000. What is the Reynolds number? Reynolds number is a pure number which indicate whether the flow of liquid is a streamline or turbulent. Remember, Reynolds number is a whole number, so it do not have any kind of units. So it is a unitless quantity. Friends, next point from this topic, it is a distinguish between the streamline flow and the turbulent flow. So this is a very important point which may be asked for the 2 marks during your terminal or annual examination. So for the 2 marks, minimum 4 points we have to write. So here I have written some important words. So while making your notes, you have to make the proper sentences. So streamline flow and the turbulent flow. What is the first point? In the streamline flow, the velocity is less than the critical velocity. That is the first point. So what is the first point? In streamline flow, the velocity of flow of liquid is less than critical velocity. So here less than word is very important. And what is the turbulent flow? The turbulent flow is the flow in which the velocity is greater than critical velocity. That is the first point. Second point, in the streamline flow, the velocity of each particle is constant. The word constant is very important. And in turbulent flow, the velocity of each particle is not constant. That is very important. Third point, when you can observe this cycle, this is a streamline flow. So in the streamline flow, no two streamline will intersect with each other. They are going parallelly. So as the parallel lines are there, they will not intersect. So what we can write, in the streamline or in the streamline flow, no two streamline will intersect each other. So here we can write never intersect. That is important word. And we can say in the turbulent flow, it do not have any kind of a fixed direction, so it may intersect. We can say in the turbulent flow, the flow of liquid will intersect, and when they will intersect, they will perform the rotational motion. So you can say the intersect word is very important. And additional point, we can say that when the two streamline will intersect each other, they can perform the rotational motion. Again, fourth point, the layers in a streamline flow are parallel to each other, and the layers of the turbulent flow are not parallel to each other. So it is related with the same point which we are seeing in the third point. Again, you can take one example. The example of the streamline flow is a steady flow of river. And what is the example of the turbulent flow? The example of the turbulent flow is a flooded river. So this is the point regarding this is a examples regarding the streamline flow and the turbulent flow. Again, I am going to explain the distinguishing point in the simple way. In the streamline flow, the velocity is less than the critical velocity. In turbulent flow, its velocity of liquid is greater than the critical velocity. First point. Second point, in the streamline flow, the velocity of particle is constant. In turbulent flow, the velocity of particle is not constant. Third point, two streamline will never intersect with each other. In turbulent flow, the liquid will intersect with each other and form the rotational motion. Again, in the streamline flow, the layers are parallel to each other. In turbulent flow, the layers are not parallel to each other. The example of the streamline is a steady flow of river. The example of the turbulent flow is a flooded river. Next point from this topic is the critical velocity and Reynolds number. So what is the meaning of the critical velocity? The critical velocity is that velocity which indicate the conversion of streamline flow into the turbulent flow. For example, suppose when liquid have the critical velocity 10 meter per second. So the liquid is moving up to the 9 meter per second, and when it reaches to the 10 meter per second, and after 10 when it will goes for the 10.1, then the streamline will be get converted into the turbulent. So what is the critical velocity? It will lies between the streamline and if the velocity crosses the critical velocity, then it will get converted into the turbulent flow. What is the critical velocity? The critical velocity is a specific velocity above which the streamline flow is get converted into the turbulent flow. So what is the formula for the critical velocity? Vc is equals to Rn into eta upon rho into d, where Vc is the critical velocity, Rn is Reynolds number, eta is the coefficient of viscosity, rho is the density of liquid, and d is the diameter of the tube. So in your textbook, the formula is given. There is no derivation. So during the examination, the question may be asked: define critical velocity and write its formula. So critical velocity is that velocity above which the streamline flow is get converted into the turbulent flow. Its mathematical formula is Vc is equals to Rn into eta upon rho into d. Friends, next is a Reynolds number. The question may be asked: define Reynolds number. So what is the definition of Reynolds number? Reynolds number is a pure number which will indicate whether the flow of liquid is a streamline or turbulent. And we can derive the formula here. Rm, that the Reynolds number, is equals to Vc rho into d upon eta. So this is the formula regarding the Reynolds number. So we have created this formula from the critical velocity formula. So friends, the equations are not given, the derivations are not given, only equations are there. So from one formula we have derived the second formula. So friends, today we have seen the fluids in motion. In that we have seen some important definition. After that we have seen what is the meaning of the streamline flow, what is the meaning of the turbulent flow, distinguishing point between the streamline and the turbulent flow, and the definition of critical velocity and Reynolds number. I hope you have understood this point. Make the notes properly, and if you have any kind of the doubts, then when you are coming to college for exchanging your books, then you can ask to the subject teachers regarding these points. Okay, you have a nice day.